Today we'll see the topic of parallel plate capacitor. As we already know that the parallel plate capacitor consists of two parallel metallic plates which are separated by a distance d, and the space between these two parallel plate capacitors are filled with a dielectric medium of permittivity epsilon. The lower plate of plate 1, carries a positive charge that is distributed with the charge density of rho s, and the upper plate 2, carries a negative charge of the charge density minus rho s. So the plate 1 is at z equal to 0, that is, it is at the xy plane, whereas your plate 2 is in the is in the z at z equal to d, placed at the distance d, which is parallel to your xy plane. Okay, so this is your y and this is your x plane. So now, as already we know that the charge q is equal to your rho s into L, whereas this L is nothing but the area that has been occupied. So I'll just replace this with rho s into A coulomb. Okay. So now this charge has a magnitude same, but they are of different charges, that is opposite charges. So assuming that plate 1 is of infinite sheet of charge, we know that this electric field intensity exists between these two plates. Okay, so to find the potential difference, we need to know what is your electric field intensity. So for that finding of your electric field intensity, let us consider your plate 1 is of infinite sheet charge, and this already we have arrived at an earlier lecture, which for your infinite sheet charge will be rho s divided by 2 epsilon into my an, which is my unit vector. Now this an is along your z plane, so I'll be just assuming this az as my a, okay, an as my az, and the unit is it is volt per meter. Okay, so now this is a consideration for my E1. What about my E2? For my E2, your charge density is negative, okay, as well as this E, electric field intensity, will be in the downward direction. So the direction of my AZ will be also in a negative case. So I can just write it as E2 is equal to rho s divided by 2 epsilon into minus AZ, volt per meter. Okay, so since it is in the downward direction, I am taking it as minus AZ. So now what will be my total electric field intensity? E will be equal to addition of these E1 and E2, which I can write it as rho s by 2 epsilon into AZ plus rho s, so this is negative because of my negative minus s. Okay, so negative into negative becomes positive, so divided by 2 epsilon into AZ. So I'll just have rho s divided by epsilon into AZ. So this is my total electric field intensity. So what is the next we need to find? We need to find what is your potential difference. So potential difference is nothing but the work done in moving a unit positive charge from your negative to positive, and it is given as dl. Okay, so this E we know. Okay, so let us write from your upper to your lower. So upper to your lower, E vector into dl vector, and this dl vector will be considering a Cartesian coordinate. Okay, so with this we'll have v is equal to minus of upper will have a distance of d as already been told, and your lower will be having a value of 0. So upper value will be your d to 0. Okay, rho s divided by 2 epsilon into az, and my dl is dx ax plus dy ay plus dz az. Okay, so now only your az component will exist, so I'll just have d to 0 rho s by 2 epsilon into dz. Okay, so after applying the limit, I'll just have rho s into d divided by epsilon. Okay, this is in terms of voltage. Finally, I have my V, I have my Q. So now I need to find what is the capacitance. So capacitance will be C is equal to Q divided by V. Q I have rho L into A. Okay, so I'll have rho L into A divided by V. I have arrived at rho L, okay, so rho S into D divided by epsilon. So this will give me epsilon A divided by D in farad. So what is your total capacitance? Capacitance C is equal to epsilon A divided by D, and you are aware what is your epsilon is? Epsilon naught into epsilon R. Okay, so from this relation we can just conclude that your capacitance depends upon your permittivity of your dielectric material that you are going to use, your area of your cross section, and the distance of separation between these two plates. Okay, so this is about your parallel plate capacitance.